So we're everywhere in this industry. We're really excited to help you make it successful. Exciting. So here's some of the things that we're already doing with VR today. Video games, obviously, entertainment, experiential, movie-type experiences. Also heavily involved in product design. Nothing better than being able to see what your product looks like before you've actually made it. So Ford and other big companies are using VR to see what their products look like before they actually build them. Architectural pre-visualization is huge. I don't know if you guys heard about that building in the UK that melts cars on sunny days. If they pre-vis that properly ahead of time, they could have seen where those reflections were and avoided that situation. So being able to pre-vis architecture ahead of time to see what it looks like is a useful thing.
Recording this.
Obviously art. I mean, who here's tried tilt brush? So tilt brush is super fun. If you ever get a chance to try it, you can create art in 3D and VR. It's an amazing experience. Next slide. So we have multiple platforms for doing VR. If you're a game developer, we have the GeForce platform, which is what most people here are probably familiar with. But we also have the Quadro platform, which is our professional graphics solution. They work typically with Hollywood, people doing product design, anything that's mission critical, where you need really good product support, you need long-term support for your drivers and things like that. They're there and involved in that stuff. And they also work with companies who need special output needs. If you're doing projection mapping, say for a stadium where you want to be able to map things onto the ice and stuff like that. That's the kind of stuff that our Quadro team does. And then we have our Tegra, which is our SoC. That's the SoC that's used in the dashboard of the Tesla car. It's also used in Lamborghinis and Audis. It's used in some VR headsets. It's also, we have an application for that for self-driving cars. What do self-driving cars have to do with tonight? Well, augmented reality is about learning where you are in the world and being able to position things. Self-driving cars, similar problem. And of course, we also have our Tesla division, which is deep learning. So that's things like functional MRIs, being able to analyze gigabytes of data in real time. So let's say you want to be able to measure a person's brain and understand what they're feeling. You need masses of compute capability to do that. But at some point, maybe we'll be able to just see what someone's feeling inside their brain. And maybe we'll even be able to pipe the images right in there. And that's the kind of stuff that the guys who are doing the supercomputing stuff are working on. Next slide, please. So NVIDIA doesn't just make chips. We provide you with a complete ecosystem. If we just gave you the chip, it wouldn't be much good. So we're going to supply you with really solid, reliable drivers, and we're also going to supply you with an SDK. And that SDK enables you to get really great performance from your VR applications. And we do that across all of the different product lines that we do. Next slide, please. So this is our SDK. There's a bunch of stuff in the SDK, and there's going to be a bunch of us over at the back later on. And we've got guys from all the different divisions over there, so come over and talk to us later about specifics. But I'm going to go into one of these features which I think is useful and interesting to game developers, well, any kind of developer. Next slide, please. So when you're doing VR, we're rendering a flat 2D image, then it has to be warped so that it looks good inside the VR headset. And some interesting properties as part of that warp. It's a barrel distortion that we have to put on. So if we go to the next slide, we're taking this image and we're actually warping it and we're pushing the edges in. The net result is we render out of the corners, we're rendering 4 times as many pixels as we need to. Now, one solution to that problem would be to render the corners of the image at 1/4 of the resolution. The trick then is if we want to render 9 different view frustums, each one with a different resolution that matches the output target of the warped image, the cost of resubmitting the geometry 9 times would be really high. But we have a technology called multi-view. And multi-view allows us to use a geometry shader and submit that stuff multiple times. Net result is we can get a really nice performance boost by reducing the pixel rate without paying extra for the geometry submission, commandless generation, all that stuff. So what that means in English is we can give you loads of performance without you having to do a lot of work. Next slide, please. So that's exactly what I'm saying. We basically cut the scene up into pieces, we render each piece at the correct resolution, and then send that out to Oculus to render. Next slide, please. So we're pleased to announce that's now supported in Unreal Engine. If you're a Unity developer and you want this in Unity, please ask Unity and they'll add it for you. And we're seeing up to 50% speed up. So that means 2 things. That means that your game can run twice as fast, but it also means that your TAM is double. We've lowered the min-spec that you need to do VR. So rather than needing a group client laptop, you only get a medium class laptop to get the kind of performance you need for a great experience. Next slide, please. Okay, so this is my nostalgia slide. So I graduated university in 1994, which is around about the time that Jurassic Park came out. If you look at this, I don't know if you can see this thing that looks like a refrigerator. So that is a Silicon Graphics printer, and that's the computers that used to make Jurassic Park. They were also in Jurassic Park. It weighed 140 pounds. Mathematical floating point was an optional extra. I think the base model came with 32 megabytes of memory. You have to get another 32 really to make it useful. Fast forward 20 years to today, everyone in this room has a cell phone in their pocket that's significantly more powerful than that. Like maybe 100 times more powerful, honestly. So, where are we going to be in 10 years' time? That's the question that you guys have to answer. That's why you're here tonight, is to show us what the world's going to look like in 10 years' time. So, next slide. So, thanks for listening. I'm really excited to see what you guys are going to be showing tonight. I think everyone else in the audience is too. Please come by and hang out with us during the break and after the pitch. Thank you very much.
Thank you, David. Do you think we can get like exclusive discount or promo code from you if we want to get any NVIDIA product? Cool. Okay. Yeah. So we will soon start our pitch session, and so each team will have 3 minutes to pitch and 3 minutes Q&A from the judges. Our judges today are Suzanne Fletcher from StarX. So she's the fund manager of StarX and has been a really great partner to us. And Professor Shousen Zhang, he is the founding partner of Empire Capital and also has been teaching at Stanford for 22 years. And Ajay Mitha, and he is the founding partner of KPCB Edge and also the investor, heavily involved in the investor